Now, our last example here, is example 518 from the book. It deals with a different scenario. HDL cholesterol has a mean of mu equal 54 and a standard deviation of sigma equals 17 in patients over the age of 50. So what that means is that if we were to go out and measure the HDL cholesterol of all patients over age 50, add them up, divide by the number of patients, we would get 54. Likewise, if we calculated the standard deviation of all those cholesterol measurements, we'd get 17. Now, let's suppose that a physician has 40 patients over the age of 50 and wants to determine the probability that their mean HDL cholesterol is 60 or more. So we've got here a sample of 40 patients, and we want to determine the probability that their mean cholesterol is 60 or more. Now, why would we want to do that? Well, that's kind of a separate question. We're just using this as an academic example to illustrate a very important point. Okay? So let's let the random variable x bar denote the mean HDL cholesterol in a sample of 40 patients. Notice that we don't use the random variable x here, we use the random variable x bar. That's because we're not dealing with just a single patient, we're dealing with the mean of a sample of 40 patients. And so the symbol that we used to denote a sample mean was x bar. That's our random variable. Okay, so we want to know the probability that x bar is greater than 60. That's what our question is asking for. Okay. And so to calculate this probability, we're going to use an extremely important result called the central limit theorem. The importance of the central limit theorem cannot be overemphasized. The central limit theorem forms the theoretical foundation for much of what we do in statistics. Much of what we do in the rest of the semester is going to be founded on this idea of the central limit theorem. Central limit theorem also has some interesting practical applications. This is just one that we're doing here. So the central limit theorem says, suppose we take random samples of size n from a population with mean mu and standard deviation sigma. And that's exactly what we're doing here. We're taking a sample of size 40 from this population, and the mean mu and standard deviation sigma were given. Central limit theorem tells us about the distribution of this random variable x bar. Central limit theorem tells us that x bar has an approximately normal distribution. That means that we can use bell curves to calculate probabilities of x bar. Number 2, the mean of x bar, denoted mu sub x, equals mu, the population mean. And then third, the standard deviation of x bar, denoted sigma sub x, is equal to sigma divided by the square root of n. And so this random variable x bar is normally distributed with this mean and this standard deviation. So we can use those three facts to calculate probabilities. And so we want to know, again, the probability that x bar is greater than 60. And so if we go to the workbook chapter 5 and the worksheet titled CLT, which stands for Central Limit Theorem, this will automatically do the calculations for us. And this works very similar to the worksheet normal, because we're dealing with a normal distribution. What we're going to do is enter our population mean, standard deviation, n, our sample size, and then these numbers a and b that we see inside the parentheses. So in this case, mu is 54, sigma is 17, n is 40. And in this case, we only see one number inside the parentheses, which is 60. So we'll enter that in both of those cells. Now, this worksheet will automatically calculate the value of sigma sub x bar. So here the standard deviation of x bar is 2.668. And then we want a probability of this form right here, that x bar is greater than some number. Now this is written kind of backwards of the way it is here, but that's okay. What's important is that x bar is bigger than the number, x bar is bigger than the number. So we want to know this number right here, 0.0128. So there's our solution, 0.0128. So there's about a 2.1 or a 1.28% chance that a sample of 40 patients is going to have a cholesterol that's greater than 60.